Hi, to write a solution for shell sort in JavaScript, the first thing we do is use this analogy to understand what is shell sort. So shell sort is an expansion of insertion sort. It basically does the same thing. Like in this case, when it basically does the same thing when shell sort use a gap value of 1. For example, so in this array here, when we use insertion sort, when the index points to the value 0 and the values before it 1, 2, 3, 4 will get pushed in its next position, and we will use the space we clean up to put in our target value. So in shell sort it was basically the same. When the pointer points to the value 0, our target equals to 0, it will start comes back based on the gap value. So 0 come back 1 gap equals to 4, 4 bigger than 0, so 4 get pushed to the position where it start counting, and 4 then will count backwards 1 gap equals to 3, 3 is bigger than 0, then 3 gets pushed, and 2 then we goes to 2 by counting backwards 1 gap, and 2 is still bigger than 0, so 2 gets pushed. So you get the idea. It does the same thing as insertion sort when gap equals to 1. So what if gap equals to other values? So in this case, if we are using insertion algorithm, so the 4 will get pushed here, then here, and here, then 1, 2, 3, 4 will get pushed backward. Backwards, and we will use the space we clean up to put our target value 0 inside. Therefore, we sort this array. But if we are using shell sort and we declare our gap value to be 4, so we actually initialize our iteration using the gap value. So 0, 1, 2, 3, 4. So we will start our iteration from position 4, pointing to this value. Then we count backwards 1 gap, 2 gap, 3 gap, 4 gap, we get value 4. So 4 is bigger than 0, so 4 gets pushed to this position. And then we will use the space we clean up to put our 0 in. So by the end of the iteration, our array will be already be sorted. Then we will go through another set of iteration using the gap value of 1. So gap value equals to 1, which is basically the insertion algorithm is compulsory for all shell sort algorithms. So in this case, no swap will take place because the array is already sorted. So in this case, in this scenario, shell sort is compared to insertion sort is easier, is cleaner. So let's start writing our shell sort using the same example we use for our analogy. So it's going to be a constant gap equals to 1, which is the compulsory one. Then we will actually later use an array of gaps. So we will just put it here first. Then we write our function called shell sort, and it's going to be taking in an input array, right? And for like always, the first thing we do is to check the input array and make sure it has enough elements inside, which is 2. So, or otherwise we return the input array, and we establish our for loop and let the iteration start at the index of our gap, and iterate through the whole array. Ask it to. Alright, so then we store our target value inside the input array at the index of the place we are pointing to, and then we should declare a variable called j, just like insertion sort, and initialize it with value I, and j is should be at least bigger or equals to gap. Why? Because let's say in this, if our gap value is equals to 2, right? So we will start with our iteration at index of 0, 1, 2 at here. So before 2, there's only one value to swap both, because we are counting backward 1 gap, 2 gap is equals to 3. And so when j is smaller than the gap, there's no need to do any swap anymore. There's only, so the first instance we need to do a swap is when j is equals to the index, and it has one value on the left hand side to swap itself with. So the condition we are using here is j bigger or equals to gap, and then we are also looking for a very specific scenario where input array at j minus gap, which is this value, is bigger than our target value, which is this value, right? Target value. All right. So after this condition is met, we will execute this block of code, and after we write this block of code, we will run j is equals to j divided by gap. So if we will write the expression like this, right? So what's next? We do exactly the same thing as in insertion. We push our value that's inside the input array j minus gap, right? And after this for block is finished running, we will be our space will be saved, and our j will be deducted into the space we cleaned up. So we will use input array j equals to our target value to finish it up. So after all of these code are finished running, our array will be sorted. So we return our input array here. Then we console log the solution and double check if our solution is correct. So sorted array dot slice, check. As you can see, our array is sorted. So this algorithm is basically rewrite the insertion algorithm with addition of a gap value here, because the gap value equals to 1. So just like insertion algorithm, we can use this algorithm to solve any array that made of numbers already. So what's next? So what makes shell sort? We are actually going to use an array of gaps. So not just one gap, the compulsory gap. So we are going to the official Wikipedia site for shell sort, and from here you can find a lot of sequence of gaps we can use that proposed by mathematicians. And yeah, we will use the one in the end, and just to be just like a FYI, so the worst scenario time complexity would be less than n square, so it's better than the worst case scenario for bubble sort, insertion sort, and selection sort. And the compulsory gap value would be 1. You see these proposals, they all have one thing in common, that they all end with value 1. So just make sure you use 1 inside your implementation of shell sort. So we put our values in here, and we do a reverse, so that we can, when we iterate the gaps, we can start from here and end with our value 1, right? So we'll do another for loop here and iterate through the gaps. So let g equals to 0 and g is smaller than gaps dot length and g++. Then we will declare a variable called gap and make it equals to gaps at the index of g. And after this is done, we just need to copy the code we write for the for loop in here, and voila, our shell sort function is finished. Let's rerun the algorithm. As you can see, again, our array is being sorted. So this is typically how you write the shell sort solution in JavaScript. Thank you for watching.